To Lesson 5, Compute Decimal Quotients. Let's dive in, shall we? First things first, pause your video, check your answers from the previous assignment, whatever that might have been, page 35, page 37. Come on back when you're ready. All right, folks, goal today will be to divide decimals with a whole number divisor. That's going to look like this, 564 and 2/10 divided by 12. Think about where we've been, multiplying decimals, to where we're going now, dividing decimals by whole number divisors. And eventually, we'll be dividing decimals by decimal divisors. And of course, we will need multiplication and division of decimals with one-step algebra. All right, go ahead and pause your video, whatever the date is, whatever the assignment number is, pause your video, come on back when you're ready. And so here we go with example 1. Now, first things first, we're going to divide and actually estimate. Don't forget to come up with a reasonable guess. Here we have 2 split into 27 parts, which is awfully close to 2 split into 25 parts. And what I'm seeing is, I don't know, about 800ths. Now, that's not going to be perfect, but don't sweat it. That's going to be okay. So let's go ahead now and divide this out. We're going to write the dividend underneath 2 and 25 thousandths, the divisor outside. Before you do anything, put that decimal place up. Now, some of you are looking and saying, but wait a second, Mr. Callan, 2 cannot be split into any 27 groups. So I'm only going to write the 0 there. Now, some of you skip this next step. For the rest of us, we're going to go ahead and subtract 2 minus 0 and then bring down the 0. Now, remember, you can add as many decimal places as you like as long as you have that big old decimal point in the right place so you're not messing up the problem changing the place values. Once again, we see that 20 cannot be split into 27 parts. So I'm going to put another 0 and now bring the next place value down. Now, I'm going to be honest, I don't know my 27, so I'm going to go out on a limb and take a guess, and I'm just going to call this 6, and let's see what happens. Well, 6 times 7 is 42, carry the 4. 6 times 2 is 12, plus 4 is 16. And when I subtract, I think, uh-oh. Now, folks, take a look at this, because this is kind of important. Our remainder is 40, but another group of 27 could have come out of that. That does not work. You cannot simply keep going and bring another place value down. In other words, the 6 is a no-go. So we're going to have to come back. We're going to have to erase that 6, and we're going to have to start over. Now, I said another group of 27 could have come out of it. So instead of 6, let's go ahead and try 7. Now, if you need to, come off to the side, multiply your 27s, and that's okay. 7 times 7 is 49. Carry the 4. 7 times 2 is 14, plus 4, 189. Now, when I subtract that, I get only 13. Now, that's a good sign, because when you look at that remainder, no more groups of 27 can come out. So please always check that your remainder is less than your divisor. I'm going to go ahead and bring a 5 down at this time. 27, how many 27s could go on? Let's try 5, shall we? So 5 times 27, off to the side again, Mr. Callan. 5 times 7 is, oh, wait a second. 5 20s is 100 and 5 7s is 35. Oh, look at that. A thing of beauty. So our final answer, 2 and 25 thousandths divided into 27 parts, 0 wholes, 0 tenths. How about 75 thousandths, which, by the way, awfully close to our estimate of 8 pennies. Pause the video, rewind if you need to go back through there. Always check your remainder. Make sure the remainder is less than the divisor. And now we'll keep going on to example 2. I'm seeing 10 split into 40 parts, which one could say is about a quarter, right? Now this is just an estimate, but at least we have a good idea in our mind before we jump in. So let's go ahead, divide 10 and 32 hundredths by 43. Always put your decimal point up before you begin. Naturally, $10 cannot be split among 43 people, so there are no wholes, but we kind of expected that. Now let's go ahead and try 2 of these, because after all, 2 43s is 86. And if we were to subtract, we would get 17 left over. Again, always making sure that in your remainder, no more of the divisor could have been pulled out. We'll bring a 2 out here. What do you think? Well, 2 of them were 86. Let's try 4, shall we? And look at there, 4 times 3 is 12, so I'm going to carry a little 1 right there. 4 times 4 is 16, plus 1 is, 17. It's a beauty. And so our final answer, if we split 10 and 32 hundredths into 43 parts, each person would get 24 cents. Hey, that's not bad. That's awfully close to our estimate. Onward we go. Apparently I skipped example 3, huh? Example 4, we got 74 and 6/10. Now think about this. 70, or maybe that's pretty close to 75, which is 1 and 15/60. Gosh, point is, it's going to be about 1 1/4. About a good estimate. Let's find out. 74 wholes, 2/10 divided into 60 parts. Put your decimal up. And in this case, well, no, you can't divide the tens. You only have 7 tens. You can't divide that into 60 parts. You can divide 74 ones into 60 parts with 14 left over. Bring a 2 down. Now remember, you can add as many place values as you want as long as your decimal is up and you're not changing the place values, you're not changing the problem. Now 2 60s makes 120, leaving us with 22. Now I got a little helper for you guys. If you're struggling with dividing by multi-digit divisors, try just crossing or covering the last digit off on both of the numbers. So how many 6s go into 22? Well, I'm going to guess about 3. Now sometimes this works, sometimes it doesn't. Sometimes you have to go a little farther up. Sometimes it's too many and you got to go down, but at least it gives you a good starting point. Meanwhile, 3 60s is 180. Leaving us with 40 left over. All right, good. The divisor is larger than the remainder. No more 60s could have come out. Now in this case, once again, let's go ahead and cover up a digit. How many 6s go into 40? Well, that's about 6. So I'm going to go ahead and divide or multiply 6 60s, which leaves 40 left over. Already looking a little strange. Some of you know where we're heading. Let me do it again. Once again, 6 goes into there, and there's another 40 coming out of it. And pretty soon you see what's happening. We will have 6s repeat forever and ever. By the way, not too bad off of our estimate of $1.25. So the final answer, this is going to be a little strange to write. Instead of just saying, writing 6 and 6 and 6 and writing dots like that, may I suggest using the repeating bar? Notice only the 6 repeats. You do not want to accidentally put a repeat bar over the 3 and the 6, or the 2, 3, because 2, 3, 6 repeated would look like this, on and on. Meanwhile, we need to make sure only the 6 is repeating, so that repeat bar only goes over that 6. All right, so a couple things to remember from this slide. Number 1, if it repeats, make sure you got that repeat bar. And if you're talking 2-digit or more divisors, you can always cover up one of the digits and say how many 6s go into 22, or you could do it again below, how many 6s go into 40, and that might help you. You might have to go a little up or a little down, but at least it'll give you a good starting point. Oh, here's example 3, except I believe that should have been 7 and 42 hundredths. Divide to the thousandths place, round to the hundredths if needed. So let's do this. 7 and 40. No, let's do 7 and 43. I'm going to stick to this problem. 7 and 43 hundredths divided by 14. And by the way, 7 divided into 14 parts, it's going to be about a half of a dollar, right? Let's go ahead and find out. Decimal point up. 7 cannot be split into 14 parts, but 74 can. Now, let's try a 5 here. 5 tens is 50 and 5 fours is 20. So 5 14s is 70. Hey, yeah, that's not too bad. Bring down our 3. 3 14s make 42. 1 left over. Now, wait a second. This is going to keep going. So let's add a 0. But 10 cannot be split into 14 parts. At this point, you could keep going, but let me look back at the directions. Directions say divide to the thousands place, and if you must, then round it to the hundredths. Well, guess what? We've already divided it to the thousands place. So I'm going to write 530 ... Now it doesn't repeat, but at least we need to show that it goes on and on. Then it says round to the nearest hundredth. And naturally, using our rounding skills, we got 53 hundredths, we got 54 hundredths. What's right in the middle? 53 hundredths and 5 thousandths. We have something so stinking close that it's pretty quick to round. This is going to be closest to 53. So again, just to be clear, our direction said both divide to the thousandths and round to the hundredths. All right, folks, one last part to crank it up a notch, and that's doing a little algebra. So we're going to go ahead, use mental math skills to evaluate each expression for the following quantities. Now, let me take a look at A. The first thing, if you don't see it, it's a dot. I'm going to go ahead for each of these. If I see an A, I'm going to substitute in 4. So here's a 4, and here's a 4. If I see a B, I'm going to substitute in a 3. So here's a 3, and here's a 3. If I see a D, I'm going to substitute in 9/10. So here is 0 and 9/10, 0 and 9/10. And last but not least is an F. I don't know if I have another color for that. Let's do purple, shall we? So 2 and 4/10 for anywhere we see F. All right, now, folks, from here, again, please focus. We're using mental math skills. So you should be able to mentally, without going off to the side, without multiplying, you should be able to say, all right, that's 36 with 1 decimal place. And if we add 3 and 6/10 with 2 and 4/10, 3 holes, 2 holes is 5 holes, but 6/10 is 4/10 is an extra hole, leading us to 6 holes. So this is what we mean by using mental math to multiply and divide quotients. Now check this out for part B. We do have 2 and 4/10, but our order of operations says before addition we do all division. Now if it were just 9 divided by 3, it'd be 3, but this is 9/10. So we're going to imagine that 3/10. Now here mental math takes over as well. Should be 2 and 7/10. Last but not least, for part C, 12 take away 2 and 4/10. Imagine going down 2. Nope, we're going down 2 and then farther. Now, I know it says use mental math, so you should be able to handle that. But if you don't understand what Mr. Calendar did, well, you don't have any dimes to take away. So you have to regroup a whole dollar to make 10 dimes. You'd have to regroup a $10 bill, and that is where you go. So just anytime you're going down the 2 holes, and then go down the 4 dimes. That's what I got, ladies and gents. For now, whatever the date is, whatever the number assignment is, go ahead and begin page 39. Numbers 11 to 21 odds, 24, 27, 30, 31. 34 to 38 doesn't say odds, so make sure you do all of those, as well as 44 to 48 all. That's what I got, folks. Take care, do well, and let's grow.